All right, so just like the intro to GeoGebra, this is an activity that most of you are going to be able to do on your own. In fact, I want you to try really hard to do this on your own without the video's help. All right, it is a discovery activity. It's developed for you to kind of make some discoveries on your own, but you are using a program that you're new to. So if you need the help, use the video, follow along, but try not to just watch and copy what I do. Try to do the work yourself and then refer to the video when you get stuck or if you feel like something's going wrong. All right, so this activity, it's called Triangle Points of Concurrency. It's going to be having you create some shapes and do some things with triangles in GeoGebra. So the first thing you need to do is go to geogebra.org and you're going to click on that same geometry app that we used before. It'll open up, and for now, you don't need to save or create anything. I guess you can save this if you want as the Triangle Points of Concurrency in case you don't get it done in one go, but that's up to you, all right? So what we're gonna do is I'm just gonna go through these instructions and kind of demonstrate how to do them. But one thing I want you to not lose track of is there's a lot of definitions in this assignment. You'll notice at the beginning of each section, like section 1, is teaching you about two different things, what a median is and what a centroid is. So it'll start with a definition. It says that a median is a segment that goes from the vertex of a triangle and the midpoint of the opposite side. So it connects a vertex to the middle of the opposite side of the triangle. All right, that's called a median. That's a definition that you need to know. So write it down in your notebook. Hit pause, write it down right now. All right, so now we're gonna go through these steps. Number 1, it says to use the polygon tool to draw a triangle. So I'm gonna go over here to my application. I'm gonna hit polygon and I'm gonna 1, 2, 3. I'm gonna make myself a triangle, okay? It doesn't matter what your triangle looks like, you just need a triangle. Step 2 says to make all the parts of the triangle green. So I'm gonna hit more, I'm gonna go select object, I'm gonna click on the triangle, and I'm gonna change it to green. A, B, and C are still blue, so if I click A, then B, then C, I can change those colors to green as well. All right, so I've got a green triangle here on my screen. Step number 3 says to use the midpoint tool to plot midpoints on each segment. So as I scroll down my tool list, go to construct, there's midpoint right there. Remember this tool, all I have to do is click on the sides of the triangle and it will automatically put a point on each of those sides. So I'm gonna put a point here, and a point there. And those are the midpoints. Again, it doesn't matter what I do to my triangle, those points are going to stay where they are. And they're always going to be in the middle, all right? Number 3, there's one more part that says to hide the labels. So I'm going to select objects E, D, and F, and I'm going to hide those labels because by the time we're done with this, how do I keep getting that one in the corner? By the time I'm done with this, my computer's going to be a mess. So let's start by hiding those midpoint labels. Number 4 says to use the segment tool to draw segments from the median to the vertex. So I need to go from, I guess, again, that's a little typo that slipped in there. We're gonna go from the midpoints to the vertex across from the midpoint. So I'm gonna go down to my segment tool and I'm gonna click on A, and then I wanna connect A to the midpoint of the side across from it. And then I'm gonna click on C and I wanna go to the midpoint across from it. If you accidentally click on the wrong midpoint like that one, you're gonna have a line that doesn't go through the triangle, which means you probably made a mistake. So undo that and let's try again. I'm gonna click on C and then this midpoint and then B and that midpoint. Again, it tells me to hide the labels. So I'm gonna click on these 3 segments I made and I'm going to hide the labels of those 3 segments. All right. And it tells me to make them orange. See, I had them selected. I should have done it then. I should read ahead. Orange and thin. All right, so they're orange, and now I use the line tool to make them thin. That makes sense because we don't want a bunch of thick lines on our screen. So these 3 orange lines, I want you to notice something. No matter what I do to my triangle, these medians all cross in the same spot. It doesn't matter what kind of triangle, but these 3 orange lines, these 3 medians, all cross in the same place. So I'm going to use my intersection tool. I'm going to scroll down to, I've got to hit more, right? I've got to hit more tools, and it's under points, intersection. And I'm going to click on any 2 of these orange lines so that I can get a point right at that intersection. I could click point and try to place one there, but if you don't put it right at the middle, right at the intersection, it can cause problems later. So we want it right at the intersection. And then it tells me to change this point to orange. So let me go back up to select object. I'm going to click on G. I'm going to change this to orange. And it wants me to change the name. So to do that, I need to go over to my 3 dots and down to settings. And I'm going to change the name to centroid. So centroid, centroid. And then I'm going to close that. So on my screen, I should see this orange dot where those intersect, and it's called the centroid. And it stays at the intersection no matter what I do. So this is one of our points of concurrency. The 3 medians cross at the centroid all the time. And there's some special characteristics about this. Before we do talk about those, it wanted me to hide my medians, which are those 3 orange lines. So if I select objects and click 1, 2, 3, not C, and then it wants me to hide those objects. So let's actually use the hide object button. Nope, not the triangle. That line, and that line. Okay. So I still have my centroid. It still works, but my orange lines are now hidden. I don't want to hide the centroid. I want to keep that there. But I do want those lines to be hidden. Now, on your notes, there's a little thing down here at the end that says for your notebook. These are some important things that you need to know about the medians and the centroid, all right? First of all, the centroid is a really cool point because it's the point of perfect balance. If you made this triangle out of wood and you put your finger right where the centroid is, that triangle would balance on your finger. That's the perfect balance point of the triangle. So I want you to write that down in your notebook. The centroid is the point of perfect balance. It happens at the intersection of the medians. And here's another cool thing, is it divides all of the medians into a ratio of 2 to 1. So what that looks like, if I have a triangle right here, and I've got a midpoint, a midpoint, a midpoint. Now theoretically, these should cross, right? But this is Mr. Reed's drawing, so it's not always perfect. So here's my centroid of the triangle that I just drew. Wow. Now here's what's cool about the centroid. If I were to break up the pieces of the segment, so this segment, this median has a yellow part and a red part right there. The yellow part is twice as big as the red part on all of these. This yellow part is twice as big as this red part. This yellow part is twice as big as this red part. That will always be true no matter what I do to that triangle. That will always remain true. The longer piece is twice the size of the smaller piece. And we're going to be using that to do some math in future homeworks. So make sure that is in your notebook. It divides the medians into a ratio of 2 to 1. If you want to use different words, you can say the long piece is double the short piece. And that will always be true if that blue dot right there is the centroid. Okay, next one, altitude and orthocenter. All right, altitude is something that you're going to want in your notebook. So stop, pause the video, copy that down. The altitude is a perpendicular segment that goes from the vertex to the opposite side. Okay, so this is a line, it's a segment that goes perpendicular to the side of the triangle, but it connects through the vertex. So this is kind of an interesting point. But make sure altitude, write that one in your notebook. It's a hard one to remember because it sounds kind of weird. So we're going to draw the altitudes. So using this same triangle, we're going to go through the next couple steps of altitudes. Number one says to use the perpendicular line tool. Well, let's start there. Perpendicular line. There we go. To draw a line from each vertex to the opposite side. So when I click on A, that's where I want the perpendicular line to go through A, and I want it to be perpendicular to the opposite side. And then C, I want to be perpendicular to the opposite side. And then B, I want the line to be perpendicular to the opposite side. So these are called altitudes, and no matter what I do to the triangle, my altitude right here at C is always perpendicular to the side across from it. It's always perpendicular to that opposite side, and it will always go through C. These are called altitudes. And if you notice, the altitudes, just like the centroid, my altitudes all cross at the same point. And sometimes, unlike my centroid, that point could be outside the triangle. Sometimes my altitudes cross. If I have an angle that's bigger than 90 degrees, it moves the altitude to the outside of the triangle. If my angles are all less than 90 degrees, then the altitude are on the inside. In fact, if it's exactly a 90-degree angle, my altitude is right on one of my vertexes. So the altitude can move according to the triangle, but they will always cross at the same place. All right, now on my worksheet, it says to make these lines purple. So I'm going to go to select object, and I'm going to pick these three lines, and I'm going to make them purple, and I think it wants me to make them, I picked C again. What is that? It wants me to make them thin lines. C is not supposed to be purple. C is supposed to be green. We're going to do that 100 times today. And it wants me to hide the labels, which I think are already hidden, if I'm not mistaken. It looks like my labels are already hidden. If yours aren't, go ahead and hide them. Okay, we want to mark that intersection. So I'm going to go down to my intersection button, and I'm going to click on any two of those purple lines. So I'm going to click on that one and that one. Did I not get intersection? I didn't get intersection. There we go. That time it worked. Click on the purple line, click on the other purple line, and it gives me a point right at that intersection that, again, no matter what I do, that point is labeled, and it's right at the intersection, okay? Now, the assignment asks me to change this point to make it purple, and we're going to change it to be called the orthocenter. That's what we call this point. It's called the orthocenter. So I'm going to select, and I'm going to make G purple, and I'm going to change the name. So I'm going to go to settings. I selected a point again, didn't I? Yep. That is so weird. All right, G, only G. And then I'm going to go to settings, and I'm going to change the name to ortho center. And when I hit X, then my ortho center should be labeled. And no matter what I do, it's at those intersections, right? Hide these purple lines. So let's go ahead while we're talking about it. Let's show hide objects. Click on each of these purple lines to turn them off, not see. And and then go back to move. That's why it's doing it. When I select objects, if C is highlighted, it automatically adjusts it too. I need to make sure to click on a blank spot. Okay, so orthocenter. Even though I can't see the lines, they're there, they're moving around. The orthocenter is moving a whole bunch. The centroid moves not nearly as much as the orthocenter does, but it moves around as well. Now, in your notebook, you need to write down information about the orthocenter. First of all, it's the intersection of the altitudes. Well, no duh, we just did that. We drew the altitudes, and that's where they intersect. Here's what's cool about the orthocenter. It's perpendicular to each side. Ta-da, nothing special. Well, of course it's perpendicular to each side because that's how we came up with it, right? The orthocenter was created to be perpendicular to the side, but that's the only special characteristic it has. It's not like our centroid that was a perfect balance and it divided something into double the size. The orthocenter is just perpendicular, right? So, next one that we're going to talk about are the perpendicular bisectors and the circumcenter, okay? So in your notes, perpendicular bisector, write that definition down. The perpendicular bisector is a perpendicular line that goes through the midpoints of the side. So the one that we just drew was a perpendicular line, those purple ones that we just hid, but they didn't go through the midpoint, they went through the vertex on the opposite side. For this one, we want those perpendicular lines to go through these gray midpoints that we have created. Not sure why we left them gray, but that's probably all right. No big deal. Okay, so step one, use the perpendicular line tool. Nope. Wrong one I'm reading here. To draw perpendicular lines through the midpoint. So I'm going to go to my perpendicular line tool, and I'm going to click on this line at the bottom, and I want that line it just created to go through the midpoint on the same line, not the midpoint. What happens a lot of times is you'll click on this green line, but then you'll click on the midpoint of a different line on accident. Don't do that. You need to go through the midpoint of the same line that you clicked on. So your perpendicular lines have to go through the midpoints. If they're not going through the midpoint, then you did something wrong, okay? Now again, these perpendicular bisectors, all three of them cross in the same place, which is another point of concurrency. Lots of special characteristics about triangles today, and that's another one. So first of all, let's make these, let's adjust these lines a little bit. So I'm going to select not C. I'm going to select, go away, C. I'm going to select these three lines, and I'm going to make them blue, and I'm going to make them really thin, right? Blue and thin, I think is what it wanted. And if there were labels, I'd turn them off, but there's no labels on mine at least. So these three blue perpendicular bisectors all cross at the same point. That point is called the circumcenter. So let's, first of all, find that point. Let's go down to intersection, and I'm going to click on one blue line and then the other blue line. And again, I get the point G. We've seen G a couple of times, but I want to change G because that's not, we don't want it to stay called G. We're going to click on it. We're going to change G to be blue, and we're going to change its name to be circumcenter, C-I-R-C. Oh, I forgot to get rid of the G. C-I-R-C, U-M center, circumcenter. Now this point, like the other ones, is going to always cross. These three lines are always going to cross. Like the orthocenter, sometimes the circumcenter, if there's an angle bigger than 90 degrees, then that circumcenter can move outside. And if you notice, it also always moves outside opposite the orthocenter. They don't move out the same side of the triangle. They kind of go in opposite directions a little bit. So first thing I want you to do, let's turn off these blue lines. Let's hide those because I don't want to see them anymore. So hide that one, and that one. And those should be gone, right? All right, so we've got the circumcenter. Couple of things that you want to add in your notes about the circumcenter. The circumcenter is the center of a circle that goes through the 3 vertexes of the triangle. Now, this is kind of cool. I'm just going to show you. You can make this on your own as well. But if I were to draw, remember in the last video, you can construct a circle that goes through 3 points. So if I click A, B, and C, I get this circle. The circumcenter is the center of that circle. No matter how big or small it gets, the circumcenter is the center of the circle, which isn't that what it sounds like? Circumcenter, circle's center. It's the center of the circle that goes through those 3 vertexes. Really cool point. That's one of the special characteristics about it. The other one is that the circumcenter is the same distance from the vertex, which kind of makes sense. If the circumcenter, if I have a circle, where can I draw? Let's draw a circle here. It's not going to be a good one. Actually, maybe, heck yeah, there we go. Perfect circle. If I have the center of the circle, no, draw, what are we doing? Come on, there we go. Center of the circle. The distance from the center of the circle to any point on the outside of the circle is what we call the radius. And it's always the same. The radius doesn't change. That distance to all of these points is the same distance. So from my circumcenter to my A, well, let's see, segment, do this for me. Circumcenter to A, circumcenter to C, circumcenter to B, those are all the same distance because all of those lines go from the middle of the circle to the edge of the circle since A, B, and C are on the edge. That is a very powerful definition that we're going to use a lot. The circumcenter is the same distance from the vertex. That needs to be in your notebook, all right? Don't forget that one. Okay, angle bisectors. Let's get rid of this extra stuff that I drew because you don't need that on your screen. You've got enough going on. Angle bisectors. We talked about this in the last video. Angle bisectors cut angles in half, right? So I'm going to use the angle bisector tool to cut all the angles of my triangle in half. So I'm going to click on this piece and then this piece, then this one, and then this one, and then this one, and that one. And remember how it made all those extra lines that we don't need? Really quick, I'm going to select, nope, I want to hide objects. I want to hide these extra lines that it created, these weird ones on the outside of the triangle. I don't want to hide the gray ones that go through the triangle, through the angles, because these lines cut the angle in half. And again, they all cross in the same place. So let's adjust these. Let's make all 3 of these. I think the assignment wants them to be red. And again, it wants them to be thin. So they're not big, thick, dark circles that we see everywhere. So these 3 thin red lines are always going to cross at the same place. It's another point of concurrency. That's what we call it. This one we call the in-center. So I want you to use your intersection button, and I want you to intersect those red lines, and then I want you to click on that G, and for the 4th time, we're going to change the color. This time we're going to make it red, and then I'm going to rename it to be in-center. So we're going to call this the in-center. And it's just like it sounds. The word in, then center. All right? So this in-center has some unique characteristics. Again, it always crosses. These altitudes or these angle bisectors of the triangle are always going to cross at that point, the in-center. What you want to add to your notebook is that the in-center, one of the things is it's the center of the in-circle, which is the largest circle that will fit inside the triangle. So for every triangle, there is, let me see if I can draw it for you, in-center and let's go, nope, that's not how big I wanted it. Let's go here, and we want to go right about there. Okay, so the in-center is a circle that fits inside the triangle. And this isn't going to work because of the way I created it. So that circle is going to change a little bit. But the in-center will always be the center of that circle that fits inside my triangle. It's the biggest circle that you can make inside a triangle. But there's something that's a little bit different about the in-center than, there are some other cool characteristics, not just that it's the center of that circle. The other one in your notebook is that the perpendicular distances from the in circle to each segment are the same length. So what that means is the distance from the in-center to, well, let's do this the right way. Undo that. I want to make let's make a perpendicular line just to make a point. So here, 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 here. And I'm going to delete that circle. I don't want that circle. No, what's going on? Okay, delete button. Delete that circle for me. Okay. And then if I make some segments really quick, you don't need to do this, but I do want to show you something. In-center to I, in-center to J. As I move this around, you've got these lines that go from the in-center to the sides of the triangle. Now, those sides are all 90 degrees. So from the in-center to J is a 90-degree angle to the side. From the in-center to H is 90 degrees. From the in-center to I is 90 degrees. Now, when those are all 90 degrees, the distance between those points is the same. Okay, the distance that you go from the in-center to the, got to get rid of that circle. It's kind of messing us up. From the in-center to that side across from it, that distance, that 90-degree distance, is going to be the same. So if I drew a triangle here and I said this was the in-center, then that means that this distance is the same as this distance, which is the same as this distance. Okay, those are always going to be the same length. And that is one of the most important pieces that you take from this assignment, because that's one that we're going to use on future assignments as well. Okay, the fact that those are the same distance we're going to use to solve problems in later homework. So make sure you write that down in your notebook. All right. So here's what I need you to do. I need you to select those red lines, and I want you to, well, what do I want you to do? I don't want you to get rid of the red ones. What I do want you to do is, right now you've kind of got the in-center, the centroid, and the orthocenter, the circumcenter all floating around. Before you print this, because I want you to turn this in, I want to see what you did, and I want you to turn it in. First thing I want you to do is grab C and see if you can create a triangle where all of those are on the same spot. And then see if you can tell why that happens or what kind of triangle it's going to make all of those be the same, okay? Second thing I want you to do is I want you to turn the colored lines back on. So go to Show Hide Object, and all of these colored lines, I don't want the gray ones. I just want the colored ones that you used to find the points of concurrency. I want all those colored lines turned back on. And I know that's kind of hard to do because some of them are small, but turn all of those back on so that when I look at your screen, of course I turned off that point right there. Turn C back on. Okay. When I look at your screen, I want to see all those different lines that you made, okay? Oh my heck, I'm turning more stuff off. I don't want that one turned off. There we go. All right, I think we're good. So this is what your screen should look like when you print it. I should be able to see the circumcenter, the centroid, the incenter, the orthocenter, and all these lines that you use to create them, okay? Don't use the triangle. I can make this really cool triangle where all of these are on top of each other, but it makes it really hard to see what you did. So don't print it like that. Let it be a mess. Go ahead and hit the three pancake things, go down to download as a PDF, and submit this on Canvas for the assignment. And then you can save it to your account as well.